It's titled Android meets TensorFlow. How many Android users or iOS developers, Android developers or iOS developers here? Almost 3. Okay. Yeah, I'd like to talk to you about how you can run TensorFlow on mobile phones or embedded systems, smaller systems. But actually, this is so important because many people would want to combine the IoT with mobile machine learning. So this is how we are trying to solve this problem. And actually, this slide is pretty new. I made it for the GDD India last week, and I had this session at GDD India with the Anita from the TensorFlow team. So this is pretty new information so we are giving. So it takes the 45 minutes, but I'd like to pick up the most important part of this session for 20 minutes. And if you have any, want to take a rest, please feel free to go to restroom. So why the ML matters for mobile or embedded or small systems or IoT devices? And this is the usual slide I use for introducing. But for mobiles, there are many machine learning use cases such as the image processing, OCR, speech to text or text to speech, translation, NLP, motion detection, anything. Because we want to make the mobile application with less traffic and faster response. And in a way, you can think the machine learning or deep learning model as an encoder or compressor compression tool for your data. For example, if you want to do some image recognition with your mobile applications, the easiest way or naive way is to send all the image data taken by camera all the way to the server where you have the server to do the image analysis. That's one way, but it takes so much traffic. So it's, you have to send all the JPEG or PNG images to the server. So instead, you can have the mobile applications running TensorFlow model inside the mobile applications to detect an object in an image and send that label to the server. So if you have a cat in an image, you can just send 3 words, CAT, to the server. That is a significant compression ratio you would get rather than sending the raw images to the server. And you can do the same thing on any kind of data by extracting the feature vector. For example, if you have a motion detection, motion sensor data in the mobile phone, rather than sending the raw motion sensor data to the server, you can extract certain bunch of numbers, feature vectors, the numbers that represents the characteristics or patterns of your motions, so that you can compress the data into much, much smaller data. And maybe the easiest way to implement this is the TensorFlow again. It's a customized ML model. And this is the same slide, skipping it. But if you want to run TensorFlow on Android or iOS right now, it's not so easy because the neural network model is too big. By default, if you're running the Inception version 3, which is one of the popular image recognition model from Google, that takes 91 megabytes for its parameters, weights, and biases. And also, TensorFlow itself has the 12 megabytes as by default. So it's too big. You don't want your users of smartphone applications downloading almost 100 megabytes of the data and binaries when just installing the application. So you want to do the optimization for mobile application, like a freezing graph, quantization, memory mapping, and selective registration. Freeze graph means you're converting all the variables for parameters into constants. So because you don't use any trainings on the mobile phones, you only want to have those parameters as a constants instead of the variables. So you can convert everything to constants so that you can remove all the checkpoints and improves the learning times. And also quantization is another important feature. Quantization means that instead of using the 32-bit floating point numbers, you can use the 8-bit integer to represent weight or biases, a parameter in a neural network model. But still, you can get a fairly decent high accuracy on the TensorFlow model. And in TensorFlow, we provide all the primitives to support quantization. So we provide the data types for the quantized 8-bit integer, or the transformation functions, quantizing or dequantizing the values, or the operations that suppose the quantized values. And now, to use all of those the techniques, we provide the new runtime called TensorFlow Lite, which is a new TensorFlow runtime and platform specifically designed for supporting the mobile phones and embedded systems. It provides a lightweight machine learning library for mobile embedded systems. Our inspiration, I can skip this part. These are smaller, faster, throughput is better. The architecture is just like that. So this is the original TensorFlow part. We are using the converter, TensorFlow Lite converter, to create the TensorFlow Lite model file, .tf Lite file. This is a new file format we are introducing, so that you can load those .tf Lite format running on the Android application or iOS application. So this is the life cycle of model. You have to use the original TensorFlow, but be careful that TensorFlow Lite will not have all the operations you have on TensorFlow Lite. We only have a subset of the operations that can be supported by the hardware accelerator in the mobile devices. But you can start using the ordinary TensorFlow development environment like cloud virtual machines or your GPU on-premise device to define and train your TensorFlow, and then use the converter to generate the TensorFlow Lite format data. And then you can run that model on the interpreter, which has the hardware support from the chipset vendors. So the TensorFlow Lite, it has the mobile file format. It uses its own lightweight format, quantization in first class, and flat buffer is the new file format we are using. It's pretty similar to the protocol buffer we are using already in the TensorFlow, but it's a new file format created originally for the video games, but it has the much more memory efficient and unmashering is necessary. So it's optimized for the lightweight, the small device use cases, and we provide the interpreter. So as I mentioned, if you use the TensorFlow binary, by default, it takes like 11 or 12 megabyte. And if you do selective registration, you can shrink it into the 1 megabyte or 2 megabyte. But by using TensorFlow Lite interpreter, you can shrink it to the 300 kilobytes or 70 kilobytes. It's so small. So you can even run these things inside very small ARM processor or something. And we provide the subset of the operations supported on TensorFlow that is focused on optimized for the Neon or ARM processor available on the smartphones. And finally, the most important part of the TensorFlow Lite is as an hardware abstraction layer for the Android Neural Network API. I'll be talking about that. Android Neural Network API is a new API that will be supported as a standard API in Android in next year, sometime next year. It's a new API, and reason why Google is introducing this is that now we have many different chipset vendors such as Qualcomm or any other vendors providing different chipsets, hardware accelerators such as GPU or digital signal processor, CPU, Neon. And right now, the developers have to be aware of those different hardware chipsets. For example, if you want to get acceleration with the Android phone right now, you have to download the SDK from Qualcomm, write some C++ code, and build your own binary, and that is not portable. So instead, we are introducing the new abstraction layer on those hardware accelerators so that sometime in next year, mobile developers don't have to think about anything about the hardware-specific things. Instead, you can just think about TensorFlow Lite that will be using the Android Neural Network API. So by using TensorFlow Lite, that will be running on the Android Neural Network API, and I'm not sure this is officially announced or not, but maybe I hope that you will be also supporting the Apple's Core ML API. So I hope that the Android TensorFlow Lite will be also easily running on the iOS applications with the Core ML acceleration support. So how do you use the TensorFlow Lite? So as I mentioned, it's not so easy. It's so easy. So you can just keep using the existing TensorFlow APIs, but you have to be careful about the operations. It is not the full operations. It's a subset of operations. So using the standard TensorFlow model with the subset of the operations, and using the existing TensorFlow API just like this, and then use the converter. Then you can use the new API that is tflite.convert method, so that you can convert the existing TensorFlow graph into the TensorFlow Lite format. And at the Android side, you can write the Gradle file to import some TensorFlow binary. And then you can run the model on the application. You can use the Java API inside the Android applications. That is so easy to use. So you can easily read all the model with the new format and apply the model to your application. So this is just released on November 14th. So it's quite new. And if you are interested in the technologies, you can go to the tensorflow.org/mobile, or we have some sample code available on the GitHub repository. And there's a demonstration applications, but I haven't tried it yet, so I can show the live demonstration. So what's the result? So as I mentioned, by using many optimization techniques, you can compress the binary interpreter size into 1 megabyte, but with TensorFlow Lite, it's much, much smaller, 70 kilobyte, 4 times faster for starting up time. And also, the size can be 4 times smaller and 50 times faster for the startup speed. And lastly, I'd like to show the very interesting use case of TensorFlow running inside mobile phones. This has been a production applications for over 1 year, and this is built by a vendor in Japan, and they have a very talented people, the experts of the TensorFlow, who even built their TensorFlow compiler to compress the model into a few 2 or 3 megabytes, and that is all about the Gymnastic exercise scorer. I have to explain what is the Gymnastic exercise scorer, because in Japan it's pretty popular to do some morning exercise, gymnastic exercise every morning by listening to some specific music from the radio, the national radio broadcast. That is called radio exercise. And millions of people in Japan are doing the same exercise at the same time in the morning. That is very hard for you to imagine, but we are doing that. And this is an application to doing a scoring on that exercise by using the motion sensor inside the smartphones. And they have built a smartphone TensorFlow deep learning model to detect every motion, and using the TensorFlow compiler to apply all the optimization techniques I have mentioned, like quantization or freezing or distillation or pruning, everything, so that they were able to shrink the tens of megabytes of model into a 2 or 3 megabytes of model. So I'd like to show a very interesting demonstration. This has a sound. I really want to show the sound. Turn on the speakers. Okay. So it should play the sound. I cannot hear the sound somehow. But anyway, okay. Oh, mute it? Okay. I did it at the last Google I/O, so it was so embarrassing. Doing a weird Japanese exercise in front of the hundreds of the Americans. And I was holding the smartphone in my hand. And that is running the application. Am I doing right? This is awkward. So just like that. So let's stop. trying to stop the application.
No. So now the TensorFlow model is trying to evaluate how well you have done with the exercise. And you can see the bar chart here. That is the evaluation by the TensorFlow model.
This is actually measured by TensorFlow model, running inside smartphone.
Okay. So go back to
Yeah, just like that. Okay. So this has been in production for over 1 year, so it's available. But this is not so easy to do, to implement for all the developers. So now we are trying to make these things very easy and available to all the developers. Hopefully sometimes in next year. So that was it. Thank you so much.